Hey students, in this video we're going to go through section 8.5, which is about the coordinate plane. Our learning target says I can plot and reflect ordered pairs in all four quadrants of a coordinate plane. So let's jump into our definitions. The coordinate plane is formed by the intersection of a horizontal number line and a vertical number line. The horizontal number line is called the x-axis. Horizontal means side to side. The vertical number line is called the y-axis. Vertical means up and down. The way I remember which is by remembering x across, y to the sky. So x goes across, side to side, horizontal, y goes to the sky, up and down. And you can see they're also labeled with an x here and a y there. The number lines intersect at the origin. In the middle, there's the origin, and separate the coordinate plane into four regions called quadrants. So there are four quadrants. Number 1 is here. Quadrant 1 is upper right. Quadrant 2 is upper left. Quadrant 3 is bottom left. Quadrant 4 is bottom right. That seems a little bit odd because it's going counterclockwise, the opposite of the way a clock moves. But someone once told me if you draw a C for coordinate plane, where you start the C is in quadrant 1, and where you end the C is quadrant 4. So if you just draw a C, where you start is where quadrant 1 should go, and you'll keep counting until where you end quadrant 4. An ordered pair is used to locate a point in the coordinate plane, some sort of point or dot in the coordinate plane. An ordered pair looks like this. It has two numbers separated by a comma inside parentheses. The first value represents the x-coordinate. It tells us on the x-axis, the horizontal axis, where that point is. And the y-coordinate tells us on the y-axis, the vertical axis, where that point is. Someone once described it to me like this. It's like you're going to first walk. The x-coordinate tells you where to walk from the origin. You always start at the origin. Walking means you're going to go left or right. And then the y value is like then taking an elevator, meaning then you move up or down. So that's how I think about it. We're always going to start at the origin. The x value tells us where to walk, left or right, and then the y value tells us where to take an elevator to, up or down. Because the origin is directly in the middle, it hasn't moved left, right, or up or down, its ordered pair is 0, 0. It is just straight in the middle, 0, 0, the origin, the starting point. So let's get into our examples. Our example 1 says which ordered pair corresponds to point T. So here's point T right there. So first, let's think about what its x value needs to be. What does the x value of point T need to be? Well, x describes the direction it's walked, left or right, from the origin. So if I start at the origin, it's moved to the right. That means it's a positive number. And it's moved to the right 1, 2, 3 times. That means the x value should be positive 3 because it has moved 3 to the right from the origin. So I can automatically get rid of A and B because those ones have x values. This is x of negative 3. I don't want that. Now I need to think about the y value. This is where I've taken an elevator. Did I take the elevator up or down from the origin? Well, I took the elevator down. That means it's going to be a negative number. How far did I take the elevator down? 1, 2, 3 down. So the y value should be negative 3. That means I can get rid of option D because it has a y value of positive 3. So the correct response should be option C, 3, negative 3. From the origin, we walked 3 to the right, and we took an elevator down 3, negative 3. Now moving into example 2, we're going to plot these 2 points in a coordinate plane and describe the location of each point. So we're going to start with point A, which is negative 2, 3. So remember, we're always going to start at the origin. That's our starting point. That's where we originate. First, the first value gives me the x-coordinate. It tells me which way to walk. Well, it says negative 2, so that means I should walk 2 to the left. I'm going to the left because it's negative. So I'm going to go right left 2 because x equals negative 2. Now, I'm not going to put a dot yet because I have not yet taken my elevator. Remember, the second value, y, tells us where to take an elevator, up or down, and how much. It says 3, positive 3, so we're going to go up 1, 2, 3. And that is where point A should end up. So we went up 3 because y equals positive 3. So again, you start at the origin, you walk left or right, negative 2 means walk 2 left, and then you take an elevator. Positive 3 means up 3. Now we're going to work with point B. Point B says 0, comma, negative 3.5. So we're going to start at the origin. First, we're going to walk. Well, our x value, 0, that means we're not actually going to walk at all. I'm going to just stay directly here. I am not going to move in the x direction. So I'm going to write no left or right. And that is again because x equals 0. It told me not to walk left or right. Now my y value is negative 3.5. This tells me to take an elevator down 3.5. Down 3.5 because y equals negative 3.5. So I'm going to go down 1, 2, 3, and then 0.5. So just right in between 3 and 4. And that is where point B should end up. So again, x and y tell us where to walk and where to take an elevator. We did not walk at all, but we took an elevator down 3.5 floors, if you want to think about it like that. Okay, now let's talk about how to reflect a point in the coordinate plane. It says to reflect a point in the x-axis, so across the x-axis, the horizontal axis, so if it's at the top going below, if it's at the bottom going to the top, use the same x-coordinate and take the opposite of the y-coordinate. To reflect a point in the y-axis, to mirror it to the left or right, because the y-axis is the vertical one, use the same y-coordinate and then take the opposite of the x-coordinate. So let's think about this. This one, it says reflect negative 2, 4 in the x-axis. So it says to reflect in the x-axis, use the same x-coordinate. X stays the same, but I'm going to take the opposite of the y-coordinate. The y-coordinate is now going to be negative 4. And that is all. I have now reflected this over the x-axis. If I imagine where negative 2, 4 is on my grid, let's look down here. I would walk left 2 and up 4. This is where it would be. To reflect it over the x-axis over this way, it ends up at negative 2, negative 4. We can see how it went from the top to the bottom. I reflected it over the x-axis just by changing the y value. Next one, I'm going to reflect negative 3, negative 1 in the y-axis. Remember, it says in the y-axis, use the same y-coordinate and take the opposite of the x-coordinate. So y is going to stay negative 1, but the x is going to take the opposite. We'll do 3, comma, negative 1. And again, I'll show you on here. If I have negative 3, negative 1, that would be here, left 3, down 1. I'm now reflecting it over the y-axis. So it's going to go over here to 3, negative 1. We went from here to here. We reflected over the y-axis by just changing the x value. So really, whichever axis you're reflecting over, that's the value you should keep. It's the other one you should switch. So if you're reflecting over x, keep x, change y. If you're reflecting over y, keep y, change x. Now the last thing we're going to do is reflect 2, 1 in the x-axis followed by the y-axis. We're going to do 2 reflections. So first I'm going to plot my point. 2, 1. Remember, we start at the origin. The x value is 2, so walk 2 to the right. The y value is 1, so take an elevator up 1. And this is where our point should be. Now, first I'm going to reflect it over the x-axis. This is the x-axis, so it's like I'm reflecting it over this. I'm doing a mirror image from here down over across this axis. That's where it should end up. So this is 2, 1. Then we moved here. This is 2, negative 1. And I'm going to write x-axis because this was reflecting over the x-axis. And that makes sense because look, we kept the x value. We took the opposite of the y value. That's what we learned earlier. Now we're going to reflect over the y-axis. So now I'm going to reflect this way. So my point should end up over here at negative 2, negative 1. This was reflecting over the y-axis. And again, that makes sense because earlier we learned if you reflect over the y-axis, you should keep the y value, negative 1, but change the x value, negative 2. So essentially what we learned is that if you're going to reflect over both axes, you just need to take the opposite of both values. So if I reflect 2, 1 over both axes, x and y, that new point should end up at negative 2, negative 1.